So what is that called? Let's first start off with the mathematical name, Kate.
Factorial.
Right, that's a factorial. It's used a lot in probability. So when we did permutations and combinations last year, the factorial was used because it's part of the permutation combination formula. Kate, what does a factorial mean?
It means that you multiply whatever number is in front of the factorial by all the numbers that precede it.
Nice, good. So if you have 8 factorial, you're taking 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So in this problem, you're asked to find the first 5 terms. So the first term I plug in a 1, which means I now have 2 factorial divided by 1 factorial. So based off of what Kate said, really that means you're taking 2 times 1, and then that's just 1. So that's going to be 2. Because 2 times 1 divided by 1 is 2. So when you plug in a 2, which now 2 plus 1 is really 3 factorial divided by 2 factorial, because you're adding 1 to the top, but the bottom stays the same number. So 3 times 2 times 1 divided by 2 times 1. It equals 3, because if you expand that factorial out, when you're dividing and you have the same terms, they cancel. So everything is being multiplied, but it's in a fraction. So when you have the top and the bottom with those same terms, they cancel and you just get 3. And that pattern continues, just showing you one more. So 3 plus 1 is 4 factorial divided by 3 factorial. Stupid thing. One of these days, this chord here won't be needed someday. So 4 times 3 times 2 times 1 divided by 3 times 2 times 1 is really just 4. So then the 4th term would be 5. The 5th term would be 6. And then the pattern would continue. Would this series have a limit?
No.
Or sequence, sorry, not series. Sequence does not have a limit because the numbers are just going to continue to go up. So I have 7, 8, 9, 10, all the way to infinity. So this does not have a limit. When it comes to a sequence, we use that word diverge. So the sequence diverges. If it has a limit, it converges to the number that the limit would be. If it doesn't have a limit, it diverges. I believe 45 had a limit of 1/2.
Yes.
So that would converge to the value of 1/2. So if I graph those, the points started up high and then they kind of curved and would level up. Any questions with 49? So the other one, number 57, gave us a cost function for some kind of product. And the cost function they gave you was $13.50 times X plus 750. And it says X would be the number of units produced, whatever we're producing, I can't remember, something. That would be the cost. It wants you to find the average cost per unit. So what would you do to find the average cost?
Divide the whole equation by x.
Right, so if I want to find the average cost per unit, meaning how much does it cost me for 1 unit instead of everything that I make, we have $13.50 plus the $47,750 divided by x. Because when you're finding an average, if I make 15 things, then I would divide that by the number of things that I'm making to get an average cost for 1 unit. So I'd have to divide that by x. Part B then said to plug in 100 and plug in 1,000 so that you can kind of see what's happening. And when you plug in 100 to that average function, so I want to figure out what the cost is, the average cost for 100 units, it was $471. But when you plug in 1,000, it becomes $59.25, I believe. So that's a pretty big difference. Clearly, you need to make more units so that your cost continues to reduce. If you only made 100, it wouldn't be worth it. You're paying $471 per unit, and you probably aren't going to charge that much for somebody to buy it. But if you make 1,000, now it's down to about $60 for you to make the unit or the product, whatever we're making. the last question then wanted you to kind of tie in that limits. So it said, as the limit approaches infinity, x approaches infinity, what would the limit of that function be? Just gonna put the cost function here. So kind of using what we've talked about yesterday with limits approaching infinity, what would the average cost be? Okay,
13.
why?
Because when you have the degree of both x's are the same, so you can just divide them and you get 13.
Yeah, so the power on the top is the same as the power on the bottom. This is now a rational function, so you can apply those properties of limits at infinity, the 3 different asymptote properties. When the powers are the same, then the limit is going to approach $13.50. So if I make an infinite amount, which after a while, if I plug in like 5,000 or maybe 10,000, if I continue to plug in numbers, you're going to see that that number is going to get closer and closer to 1350. And there's going to be a point where it's just not going to go below it. So I can't like charge, or it's not going to cost me nothing. It has to cost me something. But at some point, if we were to make a bigger T-chart, calculate some more numbers, we'd see that it's leveling off. And that anything beyond that, it would still be about $13.50 to create questions. So let's look at that lovely piecewise function. Today, a lot of the problems we do are based off of analyzing graphs. So limits really are a graphical representation. You can do a lot with one graph and answer a whole bunch of questions with limits. And you'll see that next year when you look at limits, yes, you'll look at them algebraically, but a lot of it will be done graphically as well. So if you're graphing a piecewise function, which Tuesday on your test you'll be asked to graph a piecewise function, it's so important for you to graph it correctly, because you're going to have like a dozen questions on one problem. And you need to make sure that you have an accurate graph. So when you're graphing the first one, Virginia, it says y equals negative x. What kind of graph would that create? A line, and what's going on with that line? Yeah, going down. So when you start a piecewise function, just graph the whole line. And it starts at 0, doesn't have a y-intercept, plot a couple of points going down, plot a couple of points going up. And get yourself a basic idea of what it's going to look like. So it's going to be a line. I'm not connecting these dots yet. Because then after you have those dots, you're going to look at the restriction. So this condition for the piece of the graph says x is supposed to be less than negative 2. So I go to where x is negative 2. Well, that's right here. Go to the graph that I just created. Virginia, less than means what goes on at negative 2? An open, and then which way would you shape? Or connect the points, I should say. Yeah, so you're going to the left, which is, yes, up, because that's the direction the line's going. But it's really left, because less than means left when we're talking about less than an x value. The rest of the line, if you're doing it in pencil, erase it. It's gone. So that would be my piece of the graph that applies to negative x, where x is less than negative 2. So the second piece would be the part that's in the middle. We have 1/2 x squared minus 1. And then again, you're given a restriction as to where that graph exists. Libby, what's the graph going to look like if it has an x squared in it?
It's going to be
Yeah, so it's going to be a parabola. Should look like a smiley face. Libby, what's the negative 1 do behind that x squared?
it starts with
Right, so where it starts on the y-axis. The first one started at 0 because it didn't have anything with it. This one starts down at negative 1. And then using information about parabolas, usually we go over 1 and up 1 because 1 squared is 1. But there's a half in front of it. So I have to go half the distance vertically that I normally would go. So over 1, up a half. It's a parabola. It's symmetrical. I'm going to have those same 2 points on either side. Usually I go over 2. 2 squared is 4, so I would move up 4. But I'm taking half of that and only moving up 2. And again, same thing on both sides. I don't need to go beyond 2 because it says go from negative 2 to positive 2. So I don't need to move over to where x is 3. I can stop at those 2 values. And then looking at the restrictions, x is greater than or equal to negative 2. So that means closed circle. So it's greater than or equal to negative 2, moving to the right. And then just less than positive 2. So it gets an open circle at the positive 2 mark. So closed circle on the left, less than or equal to with the number on the left. Open circle at the number on the right because it just says less than. So get a little smiley face down there. Kayla, the last one says x plus 3. Where's that graph going to start?
Plus 3.
Yeah, so that one goes up to plus 3. Again, I'm going to graph the whole line and then I'll pick the parts of the line that I need. So down 1, right 1. As it's a negative slope. And then finally that last restriction goes back to that positive 2. So here's positive 2. It says greater than, so still an open circle. If it said greater than or equal to, I'd close it. If one is closed and the other one is open, the whole thing becomes closed. And then again, greater than means move right, so we're taking the part of the line that goes to the right. So you have the open circle on the left, you have a closed circle in the middle, and then this point right here stays open because both of those restrictions were open. Questions? So underneath there are 11 questions. It says use the above graph to answer these following problems. Chelsea, what does it mean to have g of negative 5?
It makes the x values -5.
So you're not finding the limit, but you're actually finding the value that's attached with the x being negative 5. So Chelsea, in your graph, at x equals negative 5,
It's +5.
yeah, it's positive 5. So 1, 2, 3, 4, 5. Here's negative 5 going up to the graph. My point that matches the graph, the y value is positive 5. So you have x, you're really trying to find y, which is positive 5. It's just function notation. So when x is negative 5 in the function, y is positive 5. So Asia, if you look at number 2, or letter B, we have g of negative 2. So finding negative 2 on your graph, what's the y value with negative 2? Yeah. So closed circle at 1, open circle at 2. Open circle doesn't exist. So negative 2 for x has a y value of 1. Brandon, how about g of 0?
It would be -1.
Yeah, so right here, g of 0. X is 0, the y goes down to negative 1. Here's g of 2 is
1.
close. What's going on at 1? It's an open circle. What does that mean?
It's like it's not there.
It's not there. So what's g of 2? Nothing. It doesn't exist. She said it's not there because it's an open circle. So at 2, we have an open circle. That point isn't there. So the y value doesn't exist. Open circle. And then Michael, the last one here, g of 3 is
0.
a 0. That's your x-intercept. So we have a point at 3 and 0. Brandon?
Is there a button on the calculator where you can put less than, greater than?
You can get the calculator to shade. So remember how we made the calculator be that circle? If you hit that, you'll see like it'll shade above or it'll shade below.
Oh, okay.
But you can't really restrict it to like a piece of the line.
Okay.
But you can get it to shade above or below.
Do you think the more advanced calculators nowadays?
Well, you need a calculator that graphs, like your calculator only graphs in y equals form, so it doesn't graph a restriction of x.
Okay.
I'm sure there's a computer program, but not necessarily a calculator. Other questions? The other 6 underneath, they're now dealing with limits. A limit is what's happening from the left and the right of the x value. As you're approaching that, what goes on with y. So Grace, we have x is approaching negative 3. So the y is approaching. Yeah, so that's up here. So approaching negative 3, coming in from both sides, the y is going to positive 3. So that's positive 3. Sabrina, the next one, the limit as x approaches negative 1. Yeah, negative 1. Doesn't it say negative 1? Yeah, letter G. X approaches negative 1.
Sorry, I was looking at part B for some reason.
That's all right.
It's 1/2.
Yeah, it's 1/2. So down here, here's x is negative 1. The graph is approaching the value of 1/2. Not 1/4.
Isn't negative?
Negative, yes, she said. Yeah, thank And then the limit as x approaches 4. Yeah, that's down here in -1. So here's 4. Approaching it is the value of -1. The last 3 questions, 2 of them deal with those one-sided limits. So a one-sided limit is when you're looking at a specific side of the number. So you're looking at the left side if it has a negative after it. So 2 with a little negative says look at the left part of it. 2 with a little positive says look at the right side. So Kate, if we're looking at 2 and the negative side of 2, that's the parabola side. What's the limit go up to?
1.
A 1. Is that limit reached? No. So the limit is not reached. It's just the value of 1. It's okay that there's an open circle there. It's going to get really close to it. That's what a limit means. Kate, on the other side, it says approach 2 from the right. So that's the line. The limit of that is 1. Yeah, that limit is also 1. So, yeah.
Will that always work out like that? That was my question.
I think I can answer it with the, let's get this and then I'll go back to it, because I think I know what you're going to say too. So then the limit as x approaches 2, Kate, is 1, because these are the same. So adding just 2 other things down here, maybe I'll put it above so I can look at the graph. What if you were asked to find the limit as x approaches -2 from the left? That should be a G. Sorry, it's sloppy. Libby, what would happen if you have x approaches -2 from the left?
Is that?
So here's -2 from the left.
Oh, okay. It would be 2.
That would be 2. She said it's not reached. Brandon, if we had -2 from the right,
It would be 1.
it would be 1. But does the limit as x approaches -2 exist?
No.
No, because these are not the same. So from the left and the right, it has to approach the same y value. Brandon?
So whenever it says approach it from the left and you have 2 graphs that meet at that point, you have to go from the graph that actually graphs on the left
On the
side.
left,
But if
yes.
they both go to the left side, what would you do?
It wouldn't be a function if they both are on the left side.
Okay.
So it's like a number, it has one piece on the left and only one piece on the right, otherwise it's not a function.
Okay. Oh yeah, the whole thing is just one function. Okay.
Yeah, all of it together is one function.
Okay.
Jen?
If it approached infinity, would it
That's a good
not
question.
reach 0?
So she said if it was going to infinity, so if x goes to positive infinity, so as x is going to positive infinity, Jenna, where's the y value going? What kind of infinity? This guy's going negative infinity. So if the question said find the limit as x goes to positive infinity, this graph is going down to negative infinity. So it goes down to negative infinity. And I think you'll see in your homework there's a question that asks something similar to that.
Would you
So-
have to say if it reached it?
If it's infinity, it would never be reached. Yeah, because we don't know what infinity really is. Good question. Other questions? Then in your notes packet, if you turn to, I got this wrong all day. I think it's 19 and 20. I was really off first period.
What did you say?
I think I said page 13, and they were like, dude. And then last class I said 17, so I was getting closer. I'm pretty sure it's 19 and 20. Yes.
So like you had something of like a vertical asymptote row, and then you had another piece, and then you had another piece that was like landed on the vertical asymptote. Is that like neat or like
Can you draw a picture?
Yes, you did.
Yeah. Yeah.
I just had to turn it back on.
Ooh, sorry. I tell people not to throw things all the time.
I was like, what do you? I just didn't know you was happening.
So on the front of that worksheet, the first 10 problems are algebraic. Number 5, you're going to have to remember SOAP.
Oh, absolutely.
Absolutely. Because why wouldn't you have to remember SOAP? So number 5 is x cubed plus 1. You're gonna have to remember how to factor that using SOAP. 11 and 12 are 2 piecewise functions, just to keep getting you to graph those piecewise functions, feel a little bit more comfortable, but there's only one problem you have to evaluate. And then when you flip it over, there are 6 graphs. Each of the 6 graphs have 6 questions. No, there's no work to show. Like, when you're looking at a graph, there really isn't work to show with your graph. I mean, maybe you might want to draw a line to get your eye to kind of go towards the right value, but there's not work to do with graphs. I mean, this one we had to graph it. That was our work, but those graphs are given to you. And no, that's not my handwriting. I borrowed that from somewhere online. But if you post it online, it's there to share.
Well, that's a pretty good
Yeah.
handwriting.
It is really good handwriting.